Okay, we're going to graph this piecewise defined function over here on the right. It's actually question number 4, but in order to answer question number 4, I have to answer question number 1, then number 2, then number 3, and I'll bring them all together on number 4. So notice it says negative 1/2 x plus 1, and it says y equals, or f of x equals negative 1/2 x plus 1. My b for y equals mx plus b is 1, so I begin at 1 on the y-axis, and then my slope from mx plus b is negative 1/2. So I'm going to go down 1 over 2, down 1 over 2. Connect the dots in the other direction, and then make a straight line as best as I can. So there's y equals negative 1/2 x plus 1. Y equals negative x plus 0. So my b term from y equals mx plus b is 0. So I begin at 0. And my slope is negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Continue the process in the other direction. Connect the dots with a straight line. This is basically a HOI. Y equals negative 3. So it's going to be a horizontal line through y equals negative 3. Now I'm going to take this domain restriction, x is less than or equal to negative 2, and write it over here. So I go to negative 2 on the x-axis, there's nothing there. I go up to the line, I make an open circle. Now I have to decide whether I fill in the circle or not. And notice there's a line under it, so I fill in that circle. That's a closed circle now. And then notice the arrow points to the left. Arrow points to the left. So I'm only going to be concerned of what's to the left of that closed circle. I can actually come back and erase what's to the right of that closed circle. I'm going to transfer this piece over to this graph. So it starts at negative 2, positive 2, negative 2, positive 2. It's a closed circle. And the slope goes up 1, left 2. Up 1, left 2. And the arrow points to the left. So that's my first piece. Here's my second piece. I need to bring over this domain restriction where it says x is between negative 2 and 3. So x is between negative 2 and 3. And notice these both don't have a line underneath of it. I'm going to go to my curve and go to negative 2 on the x-axis, go up to the curve, put an open circle. Because there's no line on it, I do not fill that circle in. I'm going to go to 3 on the x-axis. There's nothing there. So I go down to the curve. I put an open circle. There's no line under it, so I leave that circle open. The x is between the negative 2 and the 3. So I'm only going to be interested in the piece that's between the negative 2 and the 3. So I can actually forget about what's not between the negative 2 and the 3 and erase it. Now I'm going to bring this second piece over to my graph 4. I go to negative 2, positive 2, and notice at negative 2, positive 2, I'm putting an open circle on a closed circle, and that is allowed. Then I go to positive 3, negative 1, 2, 3. Positive 3, negative 1, 2, 3, and I put an open circle there. That's an open circle because there's no line under it. I connect the dots by following the slope of down 1 over 1, 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 down 1 over 1. And notice it matches up. Connect the dots. That's the second piece of the piecewise function. The third piece is up here. So the domain restriction says x is greater than or equal to 3. So I'm going to come up here and copy that down. X is greater than or equal to 3. So I go to 3 on the x-axis. There's nothing there. I go down to the graph and I put an open circle. Do I fill that circle in or leave it open? Because there's a line underneath the inequality, I close that circle. Notice this arrow is pointing to the right. So I'm going to continue this graph to the right. That's the area I care about. Now I don't care about what's to the left of that dot. I'm going to transfer that third piece down to graph 4. And that will be the end of my piecewise defined function. I can fill in that circle, that open circle with the closed circle, and then just go to the right. And there is the completed piecewise defined function. Piecewise is the lesson. 4 more graphs. 4 more graphs. This is the actual question, but in order to graph the piecewise, I first want to graph y equals 3. Y equals 3. F of x equals 3 is the same as y equals 3. That is a HOI, a horizontal line through y equals 1, 2, 3. I'm going to graph y equals negative 1x plus 1. I begin at positive 1 on the y-axis. My slope is negative 1 over 1. So from there, I go down 1 over 1. I go down 1 over 1, down 1 over 1, down 1 over 1. Go in the opposite direction. Connect the dots with the straight line as best as you can. Number 7, y equals mx plus b. I begin at negative 2 on the y-axis. My slope is up 2, right 1. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. Continue the process in the other direction. Connect the dots. Now I'm going to take the domain restriction over to number 5. So x is less than negative 2. X is less than negative 2. So I go to negative 2 on the x-axis. There's nothing there. I go up to the graph. I put an open circle. There's no line under it, so I leave that circle open. I do not fill it in. This arrow points to the left. So I'm only concerned about what's to the left of that circle. I might as well just erase what's to the right of it. I'm going to transfer that graph over to graph 8. I go to negative 2, positive 1, 2, 3. Negative 2, positive 1, 2, 3. It's an open circle, and it's a horizontal line going to the left. My next graph, number 6. That domain says x is between negative 2 and 1. X is between negative 2 and 1. So I'm going to go to negative 2 on the x-axis, go up to the curve, put an open circle. Now, do I fill that circle in or leave it open? Because there's a line under it, I fill that circle in. That's equal to, so it's a closed circle. I go to the 1 on the x-axis, and notice, the curve is there, but it's an open circle. I do not fill that circle in. In fact, I'm going to actually erase that dot that I put there as I was graphing it, just so I know that that's an open circle. This domain says it's between negative 2 and 1. So I'm only concerned about the piece that's between negative 2 and 1. Well, shucks, I might as well erase what's to the left of negative 2 and what's to the right of 1. And I want to take that piece and transfer it over to my final answer. So I go to negative 2, 1, 2, 3. I go to negative 2, 1, 2, 3. And notice, I am allowed. It is okay to fill in an open circle with a closed circle. I go over 1. I go over to 1, 0. I put an open circle. I follow the slope of down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1 lands. Connect the dots. That's my second piece. My third piece, the domain restriction says that x is greater than or equal to 1. So I go to 1 on my axis, and notice, I'm on the curve there. I fill in the dot because there's a line underneath the inequality. So it's a closed circle. I can make an arrow out of that right arrow, and it points to the right. So I'm only concerned about this piece that goes to the right. So I'm going to get rid of what's to the left. So I'm going to transfer this graph down to the fourth graph on graph number 8. So I go to 1, 0. I fill in that open circle with a closed circle. You are allowed to do that. My slope is up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1.